Hello, welcome everybody to our first Go Meetup from 2019. We've got Bryn here, who I'm sure you've all met. If you could show the first slide, please.
Do you want some bits about?
Yeah, this is our meetup. If you need internet, here are the details. As we mentioned, the speaker is Bryn. Next slide. This is the agenda, which you all know. We've got a raffle from JetBrains at the end, so please stay till the end, basically. Next slide. And these, we actually have sponsors, funnily enough. GoBridge.
You found their logo, right?
Yeah, GoBridge, they pay for the meetup.
Yes, so Bill Kennedy, if you've heard of him, he was mostly responsible for helping us set this up in the first place a couple of years ago when we first started, and GoBridge paid for our meetup subscriptions, costs money all the time.
Okay, cool. And then Utility Warehouse is paying for the pizza, and lastly, JetBrains will pay for the raffle at the end of the talk. Next. And
there is nothing else from your bits.
Yeah, and next up is Bryn.
Okay, I'll sit this down here and we'll hope that you can hear something. You want me to clip it on to me? Oh dear. Okay, so let's go back here. I'm going to talk to you about Argo, which is a Kubernetes first workflow manager based around chaining Docker files together and some other nice bits. And how we use it. First of all, I am at FiveAI. We build self-driving cars, plus a lot of infrastructure, and we take a lot of data. There's a fair amount of research and stuff going on. So we have, well, I'll get to what we do later on. With Argo, I won't say we're hiring whilst I'm at Speechmatics because I got in trouble last time I did that. But we are always. As is everywhere. So, some links to documentation in here which we can look through if I completely run out of content, but it's a good resource, is their website. And it also has more information on the bits that are not just the core workflow manager. They have some events-driven things, and they have some CI type pipelines, which we haven't got around to using yet. There are plans for the event-driven parts for automatically triggering things. So what it is a workflow manager. It's based in Go. It works very well with the Kubernetes permissions, so they're very granular. We have teams that we don't want to be able to have access to certain bits of data, mostly because they are giving an interface that could accidentally be made public to it, and we don't want all of our model data or our training sets made real world. But we do want to be able to let the internal teams select data and download things. And we don't want people to be able to write over their colleagues' work and kill pods and mess around with the other infrastructure that is in our cluster for Kubernetes. Because we are running one large cluster auto-scaling rather than a bunch of small ones for different tasks. So the core of it, as I was saying, is a workflow manager with some add-ons for continuous integration and continuous delivery, event-based triggers from either there's a gRPC interface for calling things with parameters, which you can stick a standard HTTP or a REST interface in front of. It does some nice things with S3 bucket updates, so object renames or object uploads. You can auto trigger and go away and run your pipeline. So if you're doing data ingest pipelines, or you want to get some simple metrics out of your data, it's quite useful for those sorts of things. It uses all the fancy Kubernetes things, so it's a Kubernetes operator, and it creates its own custom object types that you can submit using either the Kubernetes command line interface or using their binary that they provide you. And it also has a lot of support for getting data in and out of it, so either S3 buckets or Artifactory, Git, HTTPS, and HTTPS, so you can run autoqueries and it will download the data view in an init container, so you can do that not on the same machine and then pass around EBS volumes, which is one of the main reasons we've chosen to do this, or to use this. They have a lot of example workflows, and I won't go through them all, and this is for passing things between stages, artifacts, job results. I think most of them are just text-based, but you can then use them to trigger in, or there are parameterized bits you can do. One of our prime types of job is running a training or an evaluation run, which requires a GPU machine, which are expensive, especially when you've got kind of a terabyte or two of data to download onto it first. So we use the workflow parts of this to download the data to a large EBS volume, and then spin up a GPU machine using Kubernetes and attach that volume, which keeps the cost down as much as we can. I think there's some of the same things done if you use SageMaker, but because we were rather than having interactive jobs, we just want to have it there as part of the pipeline. And this also then allows you to do the same thing if you have a very high CPU type job that you want. You can do the same thing without spending lots of time downloading on expensive nodes.
Sorry, Bryn, is the machine with the GPU started as part of the workflow?
So you can add standard Kubernetes resource requests to the pod or to the stage of what you're doing. So the initial stages will have a GPU required 0, and then the later one will have 1 required, and Kubernetes will then, the autoscaler will spin up a node if there aren't any available with a GPU. It does slow you down a bit because you've got to spin up a GPU node, which takes kind of 5 to 10 minutes. I think there are probably nicer, faster ways of making it happen, but you've got to go and set it all up. But it is, I think that little bit of time that you lose waiting for the machine to spin up is better than spending an hour downloading large data sets. I think there is someone at the door. So yeah, and there's a lot of examples for this, and most of my experience of this is deployment managing and trying to help people use it and setting up permissions, and a little bit of running jobs, and we're getting into that. So I have a little bit on how the workflows work. So this one here is one of their examples. Workflows are written in a YAML spec, and this one has an initial job which flips a coin, and then it runs a container based on the output of that. So it's either a true or false, and then only one of those containers get done. And you can have these branching to large numbers of branches and very, very deep trees of job. Yeah, so this is going to go very fast. Some of the examples of our things are either event-based data extraction. So when we do a data gathering run, there are useful or interesting bits of a route that we would like to look at. If the car disengaged, if there was anything that we didn't recognize, we want to get those bits of data out to be able to look at. So this is data is uploaded from a data collection site into S3. At the moment, the workflows are triggered by hand to pull out these bits of information and do the analysis, but it will go to automatic triggers, which we can do on tag bases and on other things. Data format mutation. So we take things in a very large blob, but it might be useful to make this searchable. So you can pull out certain streams of events, certain streams of messaging, because there's a lot. The big binary blob contains a lot of messages, not all of which are useful for your run. And we're looking at kind of 200-300 gig for a run file.
Small ones, data gathering activities can be the orders of close to 10 terabyte.
Okay, so yeah, and that would allow you to take out all your images, all your video files, and just select your key data streams to see what you're actually interested in. And that should take several hours. We've got some ML workflow training, which is from large public data sets for comparisons, and those take order 2 or 3 days to run. And again, model comparing of our own models internally between versions takes several days to run and generate data. And these are all happy running in the same cluster, autoscaling. They don't trample each other. At least I haven't seen any trampling yet. We'll see when we start deploying more of our internal production code into the same cluster as well, but it's Kubernetes, it should manage with doing this properly.
Do you set limits?
At the moment, because these jobs require a GPU, I haven't been setting any limits because it spins up that node and everything else in the cluster is set to be fairly agnostic to the GPU. So that's enough isolation, especially as the machines are only one GPU machines at current. So they have full utilization of that. So if we need to spin up another job, it spins up another node rather than having any dual hosting of the jobs. But there are plans to start putting it in with the kind of 8 and 16 GPU machines, and then there will be some tagging of you can have this much of the total resource in the machine, job type dependent.
Kubernetes, if you set the Kubernetes limits, you can set them also for the GPUs?
Yes, so you can set a request of a number. So I can request any number from 0 to probably about 8, because going across machine in Kubernetes is probably not good. You want to do it with MPI stuff and whatnot, which again you don't want to be doing in a cloud because you don't know where your racks are and you don't know where your things are. Although there was some interesting things about running Uber's Horvath, which does MPI stuff. Oh yeah, sorry. There were some interesting bits about running Uber's Horvath stuff, which is based in OpenMPI across Kubernetes clusters, which seemed mad. So we didn't go try and doing that because it would be hard. Yeah, needlessly hard, I think. So the way we're doing this is we started off on AWS because it was easy to go with Kubernetes. We don't have to do our own, worry about our own compute. At the moment, internal compute is a bunch of GPU machines in a server room in the building, and the engineers or the researchers have access to them. Ideally, we'd work on a workflow where it doesn't matter where you want to run a job or how you want to run a job, you just know your data location and that you've tested a container locally and you can run. And I think, and we think that this is the best way to get us to that, is moving our on-prem GPU nodes to be in Kubernetes nodes, and then being able to run the same type of submission wherever you are. So either you can run this on Minikube locally, which I don't think there's much point on, you just run a Docker container and prove to yourself that it works, and then submit it to one of the sites. And being able to do a simple test of a thing that you're going to trigger. And it just trying to find tools for people that allow them to run a job. If they find a favorite tool and then a different piece of infrastructure that might be better for them to use doesn't support that tool, they won't use it. Which means that you're stuck with supporting loads of legacy things and it gets really difficult. So multiple Kubernetes clusters that are all federated that we can just say, submit a job and it will find out where the data is for you. Seems to be the best way forward for training and for evaluation of things. What else have I got? So, good things about it that we've come up with so far is that it's fairly Terraform friendly, so I can spin up clusters for Argo and Kubernetes relatively quickly. It has a bunch of Prometheus network, Prometheus metrics for job state that you can then mix in with your standard node monitoring. So you can see what you're doing, you can see where your GPUs are being used. The nodes are generally tagged via the workflow name, so you can see if you're actually using the GPU a lot of the time, which we find probably not. Kind of GPUs is just spiky, and there are things you can do to optimize your jobs. As I say, yeah, plans to run on the on-prem nodes for making it homogeneous over everywhere. And this allows us to put ourselves close to our data. So if we have a lot of data in one of the data gathering areas and some compute there, you can equally submit jobs and be close rather than having to either wait for your 1 gig pipe to transfer kind of 10 terabytes worth of things, or any other data kind of carrying around method that we might have, which is latency of days time rather than latency of am I close to an S3-like bucket. Can't see this very well on the screen, but this is one of my favorite bits of anything, is pulling out performance graphs and looking at them and seeing that that's actually working. So we've got a job that spins up. That's at about 4 o'clock in one of the afternoons. Sits and downloads a bunch of data, most of which is in this spiky bit because it's taking a while to go actually get the node up and make its resource requests and find out where the data is. With a drop in time for activity. And then here's when the GPU node comes up and we ramp up and we do all these things. So these are quite easy to monitor and quite useful for telling the engineers what they're doing and how and when it's going on. And the workflow submitter tells you what state it's in up until you run out of your credentials for your AWS submission, which is a thing to work over. Are there any other bits that I have to say? Probably not. Extra resources for someone who actually knows a lot about Kubernetes and other bits is a talk from one of the Kubernetes developers. That's all right. On how and why it was there, where it's being used, and other places, because it is being used. Argo is being used internally at Google for providing some of their backend services, and there are a whole bunch of others that I'll go when we have a quick look at their page. They are using it in production. I'll make the slides available at the end if you want the link rather than to take pictures. I'll share them. And that was a very, very, very whistle-stop tour, because it's probably best if people ask me questions about how it's been used, because I'm not very good at preempting those. And any thoughts on it and comparisons we had to do with other workflows and other methods of doing kind of long-chained data things. So I'm open to lots of questions.
How well does it cope with what happens, obviously, when something goes wrong? When you start, the workflow kicks off and the job starts, and then your workflow seems to take some time, and it'd be mildly frustrating if they broke at the end. Do they have to go back to the beginning? Or is that down to how the workflow is implemented? Down
to how you implement that particular workflow. So if you are wanting outputs from lots of steps, you can have an artifact output from each one, so it will tar up everything that's in a certain location and stick it into an S3 bucket for you, which has lots of uses. So either for if you're running training jobs and you want to see your TensorFlow outputs for a certain part of your job, you can dump those up. You can also then, once you've got used to it, not include that and not have to spend the extra time copying it at the beginning and end of jobs. And you also can set some pod retry limits. So if it fails initially due to resource contention or something weird, it will go away and try again.
I don't know the details of Argo, but how does it compare to something like Google Dataproc?
What is Google Dataproc? Let's have a look, because I don't know what that is. It's Hadoopy things, Hadoopy Sparky things. So in Argo, you are very much in control of, well, you have to go and get the data. You can do a bit of fan out depending on some things, but you might, if you're doing large data downloads, either you want to download lots of different objects from one S3 bucket into a EBS volume, because EBS volumes are not read many. You can do it with, what's their bigger data storage NFS-like thing?
EFS.
Yeah. So
there's a bunch of other ones.
Yeah, but they do provide. Amazon do have some read multiple read things, but I haven't worked out how to do kind of persistent volume claims on those so you can map them into pods yet. You'd have to collect them via some sort of do a request, get the data sent to you, and then act on it from your local disk.
I think for EFS you end up having to implement NFS
Type client.
Persistent volumes.
Okay.
Something I was kind of looking into.
Yeah.
NFS PVCs, don't you have to provision
No, but you do have to set up. So you'll have, if you want to do something gross, you can run NFS as an actual service in Kubernetes and provide it from the nodes which you've attached into your cluster. Or you can do the NFS client provisioner, which you say, here's my NFS servers, has some volumes.
So people using it, Google, NVIDIA, for some things. I think it is one of the backends of some of the Google.
Kubeflow, I think.
Yes, I think that's it. I think that's what they're using it for. So the documentation is, if you wanted to have a play with it, I think it took me kind of half an hour to spin up in Minikube and actually get some things running, and their Helm charts are relatively sane.
Was that half an hour after you'd spent some time getting to know Kubernetes, or was that from code?
This is, so I knew how to list the number of pods and some simple things like that, but my Kubernetes experience before this is very small.
Okay.
For sharing the EBS volumes, is that something that's built into?
Yes. So so it will pass around quite happily a persistent volume claim for each workflow.
Oh, right, yeah.
So it does mean that your pipeline becomes very linear, because you only have one volume claim per job.
How deep and how wide are your pipelines?
The ones I've been doing, very, very linear. Like do a step, do another step, whatever else. But
And how many steps?
kind of 4 or 5. But I have heard of people having kind of fan outs of kind of 500 jobs, and then fan ins of that, and it seems to be coping quite well. There is a fairly active Slack group for Argo where people are saying the things they've done and what their problems are, and they will get back to you fairly quickly. And it is a very active on Git with its issues and current lambdas of pull requests. So it's getting updated very frequently. It is fairly new. And there are some little gotchas, but I think most of those are getting dealt with.
Bryn, how does it compare to Apache Airflow?
I do know Airflow, yeah. The reason that I chose this over going with Airflow, because we had a look, was the Kubernetes first kind of implementation. Airflow will let you spin up pods, but it's not what it's primarily there for. And the integration with the artifacts and the ability to do volume claims and things was, and secrets management, and the fact that it is very built into Kubernetes means I can not have to worry about engineers trying to put in their SSH tokens so they can pull things from GitLab if they want to do things, because I can store the image pull keys in secrets that are accessible in the namespace. I don't have to worry about people doing silly things, because they do a lot.
I used a tag there. You can specify the dependencies and it automatically works them out the order in which it does the tasks.
I have not, but I have played with some of the ones that do an unalinear DAG for doing kind of recursive coin flips and things like that, and it doesn't seem overly difficult to write or to understand how to do them. The jobs have like a with items and a kind of just making iterators in YAML.
Does it have a nice web interface?
It has a
And
nice,
managers.
it has a nice web. I can see what jobs have run, but it is a command line submission.
Yeah.
Or you create a pipeline and then you trigger it with an API endpoint, which I guess you could wrap a nice little front end around.
Just a kill command, for example.
Yeah, there's a kill command or a gRPC thing. If you want it to be so that you have a client and server set, so that you just can't submit random jobs. Yeah.
Is that the events framework?
Yes, that is the events framework.
Right?
Yeah, I think it's it is a extra service that gets added into the namespace, or you can run a separate workflow controller, and then your events don't get talked to in the same way. So you can set resource limits on a namespace, so that the events namespace wouldn't take up all of your compute, and your user actions wouldn't take up all of your compute either. So you actually get some fair sharing of it. And the gateways you can write there's a lot of Go examples for doing this. I can probably find one. No, that's exactly the same docs. Thanks, guys. So setting up for a webhook is just saying, open a port, listen on your load balancer, and transfer the data into here for posts. And it's just a standard Kubernetes config.
Where do you specify which workflow gets?
Which workflow gets which bit? I think that is probably down here a bit when we define the gateway talks to I will say I don't know yet, and let's go and read the docs together. But I think it's in the definition of the events workflow that you're creating. The gateway will talk to a specific named workflow type.
So the event's designed to allow you to communicate between pipelines, or I'm not sure
Okay. So
what they're for, or
events in this case are for re-triggering a workflow based on some input. So if you have you upload data relatively regularly, or you want to change if you've got like a model you want to run with a set of input parameters, you can just send a post request to an endpoint with the parameters you want to run for that job. Or if you are, our primary use for it is going to be, we'll upload an object to S3, and when it completes, there is a notify, and we can listen for that notify and then automatically process the data from that one.
okay.
There is no kind of direct inter pod or inter process communication that this provides. You could, if you were doing that, I'd like write a distributed thing with Kafka or something like that. I think there's also has the ability to do a Kafka-based trigger, so you can bundle your data together and do your thing, and then hit it with a.
So is the assumption that each step will write its data to a bucket somewhere, and the next step will go and get the data?
It's either that, or you'll create a persistent volume claim, and then you will act on that.
But they can also send a little bit of JSON data.
Yes. Yeah. So you can either it will read from the standard out of the previous one, or you can inject some JSON data between
And
jobs.
how resilient is the event? You know, like RabbitMQ cleverly detects if you lose connection, etc., or close ports and things, and reject the message and then retry it elsewhere.
So what should happen is, and this is should,
Emphasis on should.
is the workflow. You should be running more than one workflow controller, and it should kind of ram up into those. So you should be resilient in that. And then the workflow controller will say to Kubernetes, "I need some resource. Go and schedule this." And then it waits on the underlying Kubernetes scheduler to go away and do its job for it. So it should be as resilient as Kubernetes is, which depends on how well you've set up your cluster and all those bits and what's causing the contention. But it should be pretty pretty damn resilient.
As long as you pay attention.
As long as you pay attention, yeah.
Do you have to clean up the workflows that are there? Because, you apply one, it runs once, and then you don't want it to hang around.
Yes, you do. But that can be a simple, either a simple workflow or like a service you write and just let it sit there as a Kubernetes cron job type thing.
Yeah, so it's got AMQP there.
Yeah.
That's Rabbit.
And Nats and Kafka streams for input. So you'd create a Kafka listener, and then I won't go and look at all that because I haven't looked at it, so I'll just make it up as I go along.
If you're starting from scratch, would you use it again? Would you tell your former self, yes, definitely use this?
Yes, I have had a bunch of, it doesn't do this and it doesn't do that, and I'd like to use Airflow, and then I like, okay, go away and write your job spec in Airflow for me so I can see that it would work, and then show me it works, and this is much easier. This is, as far as writing a job spec to an engineer or a researcher to go and do, this is very simple YAML, put everything together. You don't have to worry about what language your underlying container is like running in, because it just runs containers for you.
Okay. So it kind of picks a container to do some work.
Picks a container, does some work. Yeah.
Get some parameters that are kind of interesting around the workflow, and then it's up to the container to go and get its data from.
Yeah. Well, the job will go, if you specify it to pick up data from the artifacts, which is S3 buckets in our case, then the job will spin up an init container that goes away and does that job for you, so you don't have to think about it, which is quite useful because then people don't have to think about how to get hold of their data. They just think, I want this data from this bucket.
Okay.
And it's much easier on the end user rather than having to go away and go, how do I get the correct permissions and the correct IAM role to go and download this data from this data set? Whereas we can handle that in the back end for everybody.
That's interesting.
And it also means that the user that the person has submitted with, if they're going, because you can have multiple users that you can log into using your IAM role, your base IAM role, and then that user has the ability to talk to Argo, but then also has the ability to talk to other bits of data, so they can only see what they're meant to see. Although the underlying controller has access to read kind of all the buckets that it needs to.
If it's aware of the data, is it clever enough to like copy it to another persistent volume if it's used like a lot, or so it does some clever optimization around that?
There isn't any clever optimization around that, no. So a persistent volume claim will last as long as the job, and then it will clean it up afterwards. You could do something like decide that you are running multiple jobs on a piece of large data, and then hand that persistent volume claim around by naming it and tagging it in Kubernetes, but
it's not going to happen automatically.
no, it's not an automatic thing, no.
And also, like, how much of the containers is reused? Like, if a lot of people use the same image, like for doing stuff, does it reuse it a lot?
Yeah, it depends on your Kubernetes image pull policy. You can tell it to pull every time, or you can tell it to only pull on changes. But I think you can set an image pull policy per namespace as well, so you can.
Since it seems to be aware of S3, is it aware of kind of
Other backends?
Yeah.
Yeah, so you can use, let me go and find this bit, because this bit's actually quite well documented.
Because one of the interesting things would be that just like kind of sharing the data, like AWS have Lustre, where it can actually be, you can pre-fill the volume with stuff from S3, and you can actually in the background tell it to push those changes back into S3.
It doesn't quite do it that smartly.
Yeah, so I'm wondering whether it's if they have something where you could actually help implement something around that service.
I don't know. You'd have to do that in a sidecar container type thing that ran with the job to watch it and push it back up as you were going. So configuration for adding S3 buckets as the default artifact is fairly simple. You set up some IAM bits and then give it the name and configure it. You can do it with Google Cloud Storage. There are Mino endpoints. Mino is has the same API as S3. And there are, so the default one it doesn't have to ask for passwords or credentials for. If you want to use non-default ones, you can tell it to point to different buckets, but you then have to give it some configuration. And there are, I don't know exactly where the instructions on this bit are, but for interfacing with Artifactory and either pulling things from Git or HTTPS downloads, etc.
And also how complex are the workflows that you can do? Can you have loops?
You can have loops, you can have lots of different things going on. Yes, I tend to not because I haven't needed to, but their examples page has kind of, the diamond here does a fan out and fan in. So this type of thing. So you get 3 jobs which come into one and then they both branch out and then go into a bunch of others. And it's probably a bit of a pain to write, but once you get used to it, the structure isn't so bad. And there are definitely loops of wait until you get this result from a thing. I think this is what you're on about creating the DAG, so it does the deciding of how its workflow goes. You just say the steps that happen and your dependencies. So you wait until you have these outputs and then you will run this stage.
And you can do recursion as well, right?
Yes.
During complete.
Yeah, I think there are some weird bits at the moment that if you try and do recursion, at least to a certain depth, it calculates the number of containers you need and then tries to spin them all up. But that is to be fixed on their pipeline, because I think we had a job that tried to spin up 500 containers and then failed quite well. It failed on the user's local Minikube example, which I'm glad it failed there rather than in production, because that wouldn't have been very fun. But there are some bits for doing retries. So if it fails, it will go ahead and rerun the job until it gets a certain number of fails or completes.
So are all your users able to create their own workflows, or are they just basically triggering jobs for workflows that are
At the moment, they're able to create their own workflows. So there's a bit of kind of documentation about how to best go and do this. Build yourself some containers using these best practice methods so that they're built in CI and tested. And once they're done and people have proved that they're happy to go, there's a small development cluster which they can test things on a very limited set of data to prove that it's working. And then there's a much larger production Kubernetes cluster.
And all your users are internal. You don't have sort of
we don't have any public facing. There are a couple of contractors, but they sit on internal VPN endpoints. So, although it would be, I think, quite possible to use this as a trigger for its external user uploading a photo or doing something and doing some pipeline on it for things. If you were to create a public endpoint for a workflow, I wouldn't want to create a public endpoint to allow job submission that was kind of unbounded, because you just get people spinning up Bitcoin miners on your clusters, which isn't going to be fun for anyone. Well, yeah, unless we can.
There's an idea.
Yeah, go away and look for all the public ends of Kubernetes clusters and run.
Just to make this a good thing, if you could go back.
If I can get back up a level into the.
There's a docs. No, what one down? It's the one up or the one up.
Okay. In the docs, there is a how to trigger.
Example Golang.
Yeah. So this is for triggering jobs from inside a piece of Go code. To wrap a rat into what we're meant to be talking about this evening, which I'm definitely not. And I think this is just calling the Kubernetes API.
In similar ways, the whole Kubernetes API gets translated into Ghost structs, which you see here.
Yeah.
So each of the YAML levels are a different struct, and then you just fill those all in, and then a bit further down in this code, you see there, you just connect to the
kubeconfig
client or something like that, and then
Yeah.
you just submit it. It's actually pretty easy.
Yeah.
So the tabs are big.
Yeah. two spaces. I think that's like, yeah, that's a big tab. Okay. I don't have any other things to show, but I'm more than happy to answer more questions if anyone has any. Like the fan in and fan out will have a gather stage, and you can then put retry policies on your internal stages that are there. Is that us? Yeah, that's us.
Okay, thanks.
There you go.